In this lesson, we're just going to walk through 2 examples of linear models and applications. Please be sure to read the document for section 1.3 because it outlines many more examples, especially if you don't feel as confident with word problems. So for the first example, we have a bank's total monthly charge for a checking account is $6 plus 5 cents per check. If your total monthly charge is $6.85, how many checks did you write during that month? So whenever we're dealing with a word problem, you first want to try to identify what you're trying to find. So what is the question asking us? Well, in this case, it's saying if your monthly charge is $6.85, how many checks did you write during that month? So we can say that X is going to equal the number of checks that we wrote. After we figure out what we're trying to find and solve for, next we want to look for any identifying phrases or numbers within our problems. So if we just read as we write, I can see that a bank's total monthly charge for a checking account. So total really means that at some point we're going to be adding. And as kind of a side note here, also posted in our course in section 1.3 is a chart of translating some English words into algebra phrases or operations. I'd be sure to take a look at that as well. So a bank's total addition monthly charge for a checking account is $6 plus 5 cents per check. So we have that total is going to mean plus. That $6 is going to come in here at some point. It seems like that $6 is a fixed cost. No matter if I wrote no checks or 50 checks, I'm still going to be charged at least $6. That word plus, again, reinforces the total that we had before. The 5 cents per check, again, 5 cents is definitely going to be important. Per means multiplication, and again, if you're not sure, check out that chart that we have posted in the course. And then the number of checks. So per check, or check is what we're trying to find, the number of checks that we have. So that would just end up being our X. Continuing to read, if your total monthly charge, so again, that total meaning when we add stuff up, is equal to $6.85, so that's good. They actually told us what the total is going to equal. How many checks do you write during that month? So again, how many checks would be our X. So there's a lot of information, but the key parts that we have is first, we're definitely going to have an addition problem between the total and the plus. We have this constant fixed cost of $6, and then we have this variable cost of 5 cents per check. So we're going to be multiplying the 5 cents by the number of checks that we have. We don't know how many checks we have. That's what our X is. And then finally, we have this total monthly charge of $6.85, which means that's what we're going to be setting it equal to. Next, we want to use all that information that we got in the previous step to set up an actual equation. So we had our total monthly charge is equal to the $6 plus, remember that $6 is a constant fee no matter what, plus the 5 cents per check, so 0.05. Per meant multiplication, and then the number of checks is what we were trying to find. So using variables only, I can rewrite charge as C equals 6 plus 0.05 times your X. And then this would set up the equation that we're ultimately going to need to solve. But that next part is that we still have a number that we hadn't used yet in order to solve this equation. Right now we have 2 variables. But if we go back to the previous page, remember that they told us that your total monthly charge was $6.85. So we were given that information. So that C I can actually replace with the $6.85. So I have $6.85 equals 6 plus 0.05x, and now it's just a matter of solving for x. So I'm going to move the 6 over, so we have 0.85 equals 0.05x, and then I would divide both sides by 0.05, and we'd be left with 17 equals x, which means that we ended up writing 17 checks during that month. So our next problem is more of a geometry problem. If we have a sidewalk surrounds a rectangular park that is 40 feet long by 20 feet wide, if the perimeter of the rectangular park and the surrounding sidewalk Measure it to 144 feet, find the width of the sidewalk. So first, again, we want to try to figure out what we're trying to find. This is pretty straightforward. That last part of the sentence just says find the width of the sidewalk. So we're going to let x equal the width of the sidewalk. Next, when we're looking at our identifying information or key phrases, I'm going to also set up a picture as best I can on the right-hand side. So a sidewalk surrounds a rectangular park. So surround means that it's going to be going around the rectangular park. And the park itself is 40 feet long by 20 feet wide. So if we try to draw a picture of this, we have a rectangular park. And I apologize as I'm drawing this, that is not the most perfect drawing that you'll ever see. But we have that the length of the rectangular park is 40 feet long. So inside we have this 40 feet and then by 20 feet. And what we're trying to find is the width of the sidewalk. So the width of the sidewalk becomes, wherever you want to think of it, that's going to be your x. So from here to here is x, from here to here is x, here to here is x, here to here is x. And I can go all the way around to illustrate that this would be x in each situation because we're trying to find the width of that sidewalk going around. And hopefully it doesn't change shape too much. So we have that the rectangular park is 40 feet long, so it's the inside part, by 20 feet wide. There is this sidewalk that goes around it, and we're trying to figure out the width. Now, another key piece of information, so we got that 40 feet long, that 20 feet wide, is if the perimeter of the rectangular park and surrounding sidewalk measures 144 feet, but perimeter, you need to remember, means that we're adding up all of the sides, and we're adding up all of the sides of the rectangle formed, including the sidewalk. So what we're talking about then would be this length down here, and then this width up here. So it's important to understand that we're going to need to figure out what that length and that width is in order to move forward with the problem. So here we have hopefully a better diagram to look at. What we need to find out in order to solve this problem is that we're given the perimeter, but again the perimeter is of the rectangle formed by both the rectangular park, which is the interior, and the surrounding sidewalk. So we need to figure out what the total length and the total width are in terms of x. So hopefully this diagram will help you to see how we're going to get those total length and the total width. Because if we look, the original inside, remember, was a length of 40, but then we had this sidewalk that got added that had a length of x and x. Well, that means that your new length is going to be 40 plus x, or 40 plus 2x. So our new length, or our total length, would be equal to 40 plus 2x. The same idea is happening with our width. So we had the 20, which was your inside for your park, that was your width, but then we had our sidewalk being added, which then extends our rectangle, so we have an additional x and x. Well, just like we had 40 plus x, because we had that sidewalk on either side, we now have for our width 20 plus x plus x. So that means that our total width would be equal to 20 plus 2x. So that's going to be helpful to us because now we were given that the perimeter was equal to 144. So that means for our equation, we would have that our perimeter is equal to our first length of 40 plus 2x plus our next width, which would be 20 plus 2x. Plus our next length, which would be 40 plus 2x, and then plus that last width, which is another 20 plus 2x, and then again we were told in the problem that this equaled 144. So from here then we can drop the parentheses since it's all addition and just combine like terms. So we would have with our numbers 40 plus 20 plus 40 plus 20, which end up being 120, plus 2x, 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 and 2x would be 8x, equals 144. Continuing to solve for x, we would have 8x equals 24, or just x equals 3. So what that means is that the sidewalk would have to have a width of 3 feet.